Example 4.2.2. Setup for this one says, you're saving for a new car. Looking at your expected income and expenses, you believe you can save $2,000 at the end of this year, $3,000 at the end of the second year, and $3,500 at the end of the third year. If you can earn 8% on your savings, how much will you have saved 3 years from today? Okay, we've got a time value money problem. So I'm going to use the three-step process that we can use to solve for any time value money problem, where step 1 is to draw the timeline and label all the information we're given. Step 2 is to look at that timeline and identify the type of cash flow that we're dealing with, so that then in step 3, we know what tools we have available to us to evaluate this particular set of cash flows. So let's start at step 1 and map this guy out. So this one has 3 years worth of cash flows. At time period 0, we don't have any cash flow because the first cash flow is not until the end of year 1, where we make a $2,000 deposit. So at the end of year 1, we've got a $2,000 cash flow. At the end of year 2, we're going to make another deposit of $3,000. And then 3 years from today, at the end of year 3, we'll make a third and final deposit of $3,500. Okay, that's all of our cash flows. We also are told that our savings are going to earn 8% interest each year. Okay, this is all the information we're given in the problem. So we've satisfied step 1. We've mapped out all the cash flows and labeled all the information that we know. Step 2 is then to look at this timeline and figure out what type of cash flow we are dealing with. So we have 3 distinct cash flows. They're not the same cash flow over and over again, so we know it's not an annuity. They don't appear to be related by any sort of set growth rate, so I don't think we're looking at a growing annuity. They do stop, so it's certainly not a perpetuity. We know we have to choose from either lump sum or a mixed stream of lump sum or some type of annuity. And this doesn't look like any kind of annuity, so I must be looking at some type of lump sum cash flow. And in fact, when I look at my cheat sheet, the second timeline that we see under lump sum looks an awful lot like this example, where we've got, just happens to be in this case, 3 cash flows. It doesn't have to be 3, it could be 2, it could be 4, it could be 20. But the key characteristic is that the cash flows are different, and they are not related by any sort of set growth rate. If that's the case, as they are in this example, and as they are in this particular problem, then we know we're looking at a mixed stream of lump sum cash flows. Okay, so a mixed stream of lump sum, and we'll use CFs for cash flows. Okay, once we've got that figured out, we know we're dealing with lump sum cash flows. Then we want to use whatever tools are available to us, whichever tool we'd prefer to use, to evaluate this particular series of cash flows. And if we're looking at a lump sum cash flow, we can see on this sheet that we have 3 tools available to us. We can use the present value, future value of a lump sum formula, which we have 2 different versions of, or we could use the time value money keys in a financial calculator, or we could use a spreadsheet. This video, like the others, is going to focus on the formula solution and the financial calculator solution, just because the spreadsheet is not typically available to students in an exam environment. So we'll focus on the 2 that are actually relevant to what we're trying to do in this class. All right, and we'll look at both in this video. We'll start with the formulas, and then we'll move on to the financial calculator. Okay, so we know we're using the present value, future value relationship, which is shown here in equation 3.2. We have multiple cash flows, so we're going to end up stringing 3 of these guys together, like we see in equation 4.01, but these 2 are really the same formula. Equation 4.01 just strings together a series of the equations that appear in 3.2. So, but we have 4 variables in this equation. We've got present value, we've got future value, we have the interest rate, and then we have the number of compounding periods. So we have to figure out which one of those 3 we're actually solving for in this problem. And we can figure that out by reading the end of this question again. It says, if you can earn 8% on your savings, how much will you have saved 3 years from today? Okay, so we are looking for an accumulated value at the end of our timeline. that is what we call future value. All right, so we're trying to figure out what the balance in our account will be at the end of year 3. That is immediately after we make the deposit of $3,500. That means this $3,500 that we deposit is not going to earn interest at all, but our previous 2 deposits will. This $3,000 deposit 2 years from today is going to earn interest for 1 full year by the time we make our last deposit. And that initial deposit of $2,000 is going to earn interest for 2 years by the time we accumulate that final value. All right, so we know we're looking for future value. So we can use the future value version of the present value future value formula, which is future value is equal to present value times 1 plus r raised to the n, where n is the number of compounding periods. This version would be for a single cash flow. In this case, we have 3 cash flows, so I'm going to string 3 of these guys together. And to keep track of all the cash flows, I'm going to use subscripts. So I'm going to say the future value sub 3, that means as of the end of year 3, is equal to the present value of this first cash flow that happens at the end of year 1. So I'm going to say present value sub 1 times 1 plus r, our interest rate factor, raised to the n. Well, for this $2,000 cash flow, that's going to earn interest 2 periods. From the end of year 1 to the end of year 2, it'll earn interest 1 time. And then from the end of year 2 to the end of year 3, it'll earn interest a second time. So we need to square that guy because it's going to earn interest 2 periods. Okay, I'm going to add to that present value sub 2, which I'm going to use to stand for this $3,000 cash flow that happens at the end of year 2. And we're going to need to multiply that times 1 plus r, our interest rate factor. And this time, that deposit is going to earn interest just 1 period. So we can raise that guy to the 1. And then we need to add to that, I'm going to say PV sub 3 to stand in for this $3,500 deposit that happens at the end of year 3. Now that one is not going to earn any interest by the time we're interested in knowing what the account balance is going to be. We're just going to deposit it, and then it's going to be there added to what was already there. So we don't need to multiply that by the interest rate factor at all to get the future value that we are looking for. Okay, now let's plug in the values that we actually have from this formula. So PV sub 1 we're using to stand for the 2,000. We're going to multiply that times 1 plus r, where r is our interest rate. That's 8% in this problem. Expressed as a decimal, that's 0.08. So 1 plus 0.08 is going to be 1.08 raised to the 2, because we're going to earn interest 2 periods on that $2,000. We're going to add to that PV sub 2. That's what we're using to stand in for this $3,000. And then we'd multiply that times 1.08. This time just to the 1, because it's only going to earn interest 1 period. And then we need to add to that the $3,500 final deposit that's not going to earn any interest at all. All right, future value sub 3 then, or future value as of the end of year 3. Let's just plug these guys into the calculator and see what we get. 2,000 times 1.08. Press the x squared key to raise that to the 2, and then equals to do the multiplication. That's going to be $2,332.80. And just as a matter of habit, we can see this one worked out to a nice even number. I don't have a repeating or decimal or any kind of irrational number, but I like to go ahead and store my values at intermediate steps just to be in the habit of using as much precision as my calculator can offer me. So I'm going to go ahead and store that guy on the 1 key by pressing STO1 while it's on the display, and that stores the full 13 decimal version of this number. All right, the next one is 3,000 times 1.08 equals 3,240. And again, I'm going to store that on the 2 key. It's not going to make any difference in this case because it's a nice, it rounds off to the nearest dollar anyway. But again, just as a matter of habit, so I don't forget to do it on a later problem where it really does matter, I'm going to go ahead and store it because that's what I do on every problem. All right, now we want to add these guys together. Find the future value as of the end of year 3. The 3,240 is already on there, so I'm going to leave it there and just say plus recall 1 to get that number. Plus recall 1 will give me the $2,332.80. And then I can say plus and just type in the 3,500 to get a total future value of $9,072.80. Okay? And that is what we were looking for in this problem. Finding that future value means that after we make 3 deposits, we make an initial deposit of $2,000 1 year from today, earns interest 2 years. We make a second deposit of $3,000 1 year from today, it earns interest for 1 year. And then when we make our final deposit of $3,500, our bank account balance is going to be $9,072.80, and that's what we'll have available to make a down payment on a car, or that could be a decent car all on its own if we just wanted to pay cash, I guess. Okay, that's the formula solution. Let's look at the calculator solution now. And in this case, we're actually going to use the time value of money keys. And on 4.2.1, we were able to use the cash flow worksheet. That's because we were looking for present value. In this case, we're looking for future value, and I'm not aware of a clean way to use the cash flow worksheet to do that. So we're going to use the time value money keys, the N, I over Y, PV, PMT, and FV, and we'll just have to deal with each cash flow individually. So let's start out by finding the future value as of the year 3 of the initial $2,000 deposit. Okay, for that initial $2,000 deposit, we'll put it in at the end of year 1, and it's going to earn interest 2 periods. So we need to compound that guy 2 periods and figure out what its future value is going to be. So our time value money keys are, I like to lay them out vertically in my notes just to keep track of what all I've entered on the calculator since I can't see it all at once. And I write them in the same order that they appear left to right on the calculator. So N, I over Y, PV, PMT, and FV. I've written them in the same order vertically. There's no magic to writing it like this. It's just the habit that I got into as an undergraduate student, and it's what I still use today. You can adopt any system you want, but I encourage you to adopt a systematic way of entering it. That is, do it the same way every single time, because that lessens the odds that you'll forget to put something in and maximizes the chances of you remembering to put all the values in. Okay, for this $2,000, our N is 2. We've got 2 compounding periods. Our interest rate is 8. When we're using the time value keys on the calculator, it's expecting an interest rate on the I over Y key. So we don't need to turn it into a decimal. We will not enter 0.08 for I over Y if it's 8%. Instead, we'll put in 8, and it will know that that is 8%. Present value is 2,000. That's what we're starting with. And for the time value money keys, we need to keep track, or we need to tell the calculator the relative direction of the cash flows. And as a matter of habit, I tend to adopt the perspective of my pocket to look at how the cash flows are moving. For this one, I'm taking $2,000 out of my pocket and putting it in my bank account. So I'm going to record it as a negative just to say it's a cash outflow. It doesn't really matter in this case. Since I'm going to enter it as a negative, payment is going to be 0 because we don't have any reoccurring payment. And then I'm going to solve for future value. When I put the present value in as a negative, it's going to give me a positive future value just to say that the cash flow is moving in the opposite direction. If you instead enter the present value as a positive, you're going to get a minus sign on the future value, but it'll be the exact same number. The calculator is just telling you that the cash flows are moving in opposite directions. Okay, let's put this guy in. We'll start, as always, by clearing out the time value money keys by hitting second and clear TVM. That zeroes everything out. And then I'm going to work left to right. I want to store 2 on the N key, so I'll type 2 first, and then press N to store it. I over Y is 8, so I'll type 8 and press I over Y. Present value is 2,000. I'll hit plus minus key to make it negative, and then press the PV key to store it. Payment is 0, which it's already 0 because we cleared it out, but just to be sure, I like to go ahead and put 0, record 0 on the payment key to make sure there's really nothing else there. And now we can solve for future value by hitting compute, CPT in the upper left, FV. And it's going to work that same formula that we worked to find that the future value of that first deposit is $2,332.80. $332.80, which is the same thing we found in the formula here. The calculator's doing that for us. We're just not having to work the actual formula to get it done. All right, now let's find the future value of that $3,000 deposit. All right, well, while I'm here, just like I did before, I'm going to go ahead and store this value. I'm going to hit STO1 there, and I'll write a note to myself to say that I stored that on the 1 key, so when I want to go back and use it later, I'll remember where it's at. All right, so then the future value of 3,000, we're going to use the time value money keys again. N in this case is just going to be 1 because we deposit that 3,000 at the end of year 2 and it accumulates interest for just 1 year out to the end of year 3. So for this $3,000 deposit, N is 1, I over Y is still 8. The present value that I'm starting with is 3,000. Again, I'm going to call it a negative just because I'm using the perspective of my pocket. It doesn't matter. You can record it as a positive if you want. Payment is going to be 0 again because there's no recurring payment, and then future value is what I'm looking for. So I will put a question mark there. We'll clear out our time value money, and then 1 is N, 8 is I over Y, 3,000 as a negative is our present value, 0 is payment, and then compute future value. And we find $3,240, which I will store on the 2 key. And notice that that is the exact same value that we came up with in the formula for the future value as of the end of year 3 of that 3,000. Okay. So the calculator's just doing the same thing for us. We're just not having to work the actual formula. All right, the total future value then, as of the end of year 3, we've got the initial $2,000 deposit expressed in end of year $3. That's $2,332.80. That's what we found right here that we have stored on the 1 key. We need to add to that the $3,240, which is what our $3,000 deposit will grow to by the end of year 3. And then we also need to add to that our final deposit of $3,500, which is already expressed in end of year $3. Okay, so then we just add these 3 values together. They're all expressed in end of year $3 now, so there's no problem in combining them. So that one plus recall 1 plus 3,500 equals, and we get the same future value as before. We get $9,072.80. Okay, now of course, there's no reason to walk through both of these solutions when you're working a problem for your homework or for an exam. You pick the one that you're most comfortable with and use that. I'm just walking through both of them in these first examples because some students are comfortable using the time value money keys in the calculator, and then some are more comfortable using the formulas for quite a while. And in addition to that, it helps to see, even if you're not using the formulas, I think it helps to see the formulas at work, seeing how the arithmetic works out to understand the relationship between present value and future value, interest rate, number of periods, and all that. Instead of just punching keys on the calculator, it can be really hard to develop an intuition behind the time value money if you're just going straight for the time value money keys. So that's why these videos will include both of them, but there's no need for you to do both of them as you're working the problems, of course.